The weapon began as an engineering requirement, a silenced shoulder weapon for specialist ground units. The specification asked for minimal acoustic signature. The specification also demanded reliable lethality at short distances. British planners selected existing components as starting points. They preferred modification over entirely new manufacture. The short magazine Lee-Enfield Action was chosen. It was familiar to armourers across British depots. The Action provided strong locking lugs and robustness. It tolerated mud, rough handling and poor maintenance. However, its original .303 rifle cartridge was unsuitable. The .303 round produced supersonic crack and flash. Engineers required a naturally subsonic projectile. They also required a heavy bullet for impact. The .45 ACP pistol cartridge met these parameters, and its typical velocity remained comfortably below sonic threshold. Using .45 ACP simplified ammunition sourcing for commandos. It matched the Colt automatic sidearm already issued. Common ammunition eased resupply under irregular conditions. It also removed the need for specialised subsonic loads. Adapting the Lee-Enfield to the .45 ACP required surgery. The original barrel was removed and scrapped. Thread dimensions on the receiver were carefully measured. A new threaded interface was machined to specification. A Thompson submachine gun barrel formed the core. Its bore and rifling suited .45 ACP ball. The barrel was shortened to suit compact handling. Porting holes were drilled along its forward length. These ports vented high-pressure gas laterally. Gas entered the expansion volume surrounding the barrel. The pressure dropped before the bullet reached the muzzle. This reduced both muzzle blast and residual flash. The suppressor body enclosed barrel and expansion chambers. It occupied more than half the apparent weapon length. The tube diameter was large relative to typical silencers. The volume allowed hot gases to expand and cool. Internal baffles divided the suppressor into sequential chambers. Each baffle contained an aperture only slightly above bore diameter. Edges around the apertures were machined to sharp profiles. This disturbed gas flow and stripped energy from turbulence. The suppressor tube was permanently fixed to the receiver. Field removal was not intended during normal operations. Armourers could unthread the tube only with tooling. This limited unauthorized modification by unit personnel. The wooden forend no longer gripped the barrel. Instead, it formed a handguard around the suppressor body. Contact points were carefully spaced to avoid resonance. Loose contact could amplify mechanical noise under firing. The bolt face no longer matched .303 rimmed cartridges. A new bolt head was turned for .45 ACP. The recess depth matched the pistol case head thickness. Extractor claw geometry was adjusted for straight-walled brass. The feed path required major alteration of the magazine well. The original Lee-Enfield box was removed entirely. A block was machined to occupy the vacant space. This block supported a vertical pistol magazine housing. Modified Colt pistol magazines locked into this housing. A catch at the rear secured the magazine lip. Release was performed by depressing a simple lever mechanism. And this arrangement prioritized secure retention over rapid changes. Feed angle from magazine to chamber was non-trivial. The .45 cartridge was short relative to action length. Engineers used feed ramps cut into the adapter block. They polished these ramps to reduce friction and hesitation. The bolt travel greatly exceeded the necessary feeding distance. This created potential for nosedives and misalignment. To mitigate this, bolt stroke was partially shortened. Travel stops were integrated to limit rearward movement. The shortened throw slightly increased operating speed. However, rate of fire remained user-controlled manually. The action remained strictly bolt-operated throughout development. No provision was made for semi-automatic cycling. Manual operation was considered beneficial for acoustic control. The operator could decide when to cycle. If the first shot resolved the engagement, cycling waited. This prevented unnecessary mechanical noise after a single discharge. Test memoranda noted that bolt noise exceeded muzzle report. The firing signature at distance was unusually low. Observers at controlled ranges often heard only bolt movement. Muzzle blast remained masked within background environmental sounds. To reduce mechanical signature further, contact surfaces were examined. Cam tracks on the bolt body received careful stoning. Burrs were removed from locking lug bearing areas. Lubrication points were specified with detailed oil-grade references. Some prototypes experimented with padded bolt handles. Rubber or composite inserts damped impact against the receiver. These inserts aged poorly under field conditions and oil. The concept was limited to small experimental batches. Finalized production rifles used simple steel bolt knobs. Ease of manufacture outweighed marginal acoustic benefit. Inspection records show emphasis on dimensional consistency instead. Noise control relied primarily on suppressor volume and ammunition. Weight distribution differed significantly from standard service rifles. Mass concentrated forward within the suppressor assembly. This produced a distinctly muzzle-heavy handling characteristic. Close-range stability, however, was considered acceptable and manageable. Overall length remained shorter than many full-length rifles. Parachute and commando units valued compactness during movement. A small number received folding stock experimental variants. These retained the same suppressor body and barrel configuration. The sighting system reflected limited expected engagement distances. Simple aperture rears and plain front posts were fitted. Adjustments prioritized course elevation rather than fine windage corrections. Technical literature acknowledged practical ranges under 200 yards. Accuracy requirements were secondary to acoustic performance and reliability. Grouping standards during trials reflected practical sentry engagement conditions. 4-inch groups at 100 yards were acceptable. Further tightening would have increased production time and rejection rates. Manufacturing began with a pilot batch at Ford. These units were effectively hand-built workshop conversions. Individual receivers showed traceable marks from original service rifles. Serials from earlier infantry service continued on into conversion, and each receiver was stripped and inspected microscopically. Cracks in locking recesses resulted in outright rejection. Threads were gauged with certified ring gauges and plugs. Only receivers within tolerance entered the conversion line. Barrels sourced from Thompson stock required reworking. Chambers were polished and checked with go gauges. Non-conforming barrels were set aside for training only. Operational carbines received barrels meeting strict concentricity criteria. Suppressor tubes were rolled from mild steel strip. Longitudinal welds were ground flush to avoid interference. Interior surfaces were not polished to high finish. Slight roughness promoted turbulent flow and energy dissipation. Baffles were stamped on dedicated press tooling. Each disc contained a central pilot hole before boring. Final aperture diameter was controlled to tight tolerance bands. Off-center apertures risked baffle strikes and catastrophic failure. Assemblers stacked baffles in predetermined orientations. Some included radial notches to interrupt direct gas paths. Spacing rings preserved consistent distances between individual partitions. The stack was then secured within the tube with welds. Finished suppressor assemblies were pressure tested with proof loads. Overpressure cartridges expanded gas volumes beyond normal operating conditions. Inspectors monitored for bulging, leakage, or weld failure. Defective units were scrapped rather than reworked in service. Furniture components used walnut or similar hardwood stocks. Existing SMLE stocks were modified where practical for reuse. Inletting changed to accommodate the larger suppressor body. The handguards were widened and vented to reduce heat buildup. Surface finish for metalwork used parkerized coatings. The coating system provided corrosion resistance under maritime conditions. It also reduced visible reflections under artificial light sources. Bright surfaces on sites alone received selective hard burnishing treatment. Production later shifted to a specialist arms manufacturer. This phase introduced more standardized jigs and fixtures. Tolerances tightened slightly as experience accumulated from earlier batches. Documentation from this period shows refined assembly instructions. Quality control routines included repeated test firing cycles. Weapons were proofed, zeroed, then cooled and rechecked. Some sample units underwent extended endurance firing with standard ammunition. The silencer components were inspected for progressive fouling and erosion. Suppressor cleaning procedures received special attention in manuals. Operators were instructed to avoid complete disassembly in field. Instead, they soaked the front assembly in solvent baths. Armourers later removed accumulated carbon during scheduled workshop maintenance. Extended firing produced carbon accumulation around baffle edges. This gradually altered internal geometry and flow characteristics. Noise levels increased marginally after heavy, continuous usage. However, carbines remained significantly quieter than most alternatives available. Ammunition selection remained conventional across the program. Standard ballpoint .45 cartridges were issued, without special markings. Reloading or experimental subsonic loads were not encouraged. So consistency in manufacturers reduced deviations in muzzle velocity spread. Reports recorded negligible flash signature at her night firing. Observers located downrange often failed to identify origin. Acoustic directionality was distorted by environmental reflections and obstacles. This characteristic served planners interested in clandestine applications. The weapon's magazine capacity remained lower than submachine guns. 7 or 8 rounds were typical depending on magazine pattern. Some evaluators considered this capacity marginal during multiple target engagements. However, designers prioritized quietness over volume of fire. Bolt operation under stress presented specific ergonomic issues. Shortened travel demanded retraining for experienced Lee-Enfield users. Muscle memory from full-length actions could cause incomplete cycling. Then training notes emphasized deliberate rearward motion until defined stop. Extraction reliability depended on clean chambers and good polish. Dirty ammunition could cause partial case adhesion during extraction. Such events increased mechanical noise as users forced bolts. Armourers were instructed to monitor chamber finish regularly. Environmental testing included use in tropical humidity conditions. Suppressor internals showed susceptibility to condensed moisture retention. Water accumulation slightly altered first-shot acoustic characteristics. Hence, storage guidelines recommended muzzle-down orientation when practical. Field feedback from operations highlighted strengths and weaknesses systematically. Operators appreciated minimal recoil impulse from the heavy assembly. The combination of suppressor mass and pistol cartridge mitigated recoil. Rapid follow-up shots remained controllable despite manual cycling. On the negative side, overall weight was substantial. Carrying the carbine alongside other specialist equipment caused fatigue. Some units carried it as a secondary task-specific weapon. Primary fighting arms remained lighter carbines or submachine guns. The external profile drew attention within conventional units. Its long suppressor and compact barrel looked unconventional. Some contemporary correspondence describes it as visually unattractive equipment. Appearance, however, had negligible influence on procurement decisions recorded. Distribution remained limited to selected commando and special service organizations. Numbers produced never approached conventional service rifle quantities. Their inventory records show controlled allocation under restricted issue lists. Weapons were often signed out for specific operational tasks. Procurement files refer to discussions around alternative suppressed systems. Silenced Sten models were available and broadly distributed elsewhere. These offered higher magazine capacity and automatic fire capability. However, their sound signatures remained higher than the integral carbine. Bureaucratic debate weighed manufacturing complexity against operational advantage. The integrally suppressed carbine demanded more skilled machine work. Silenced submachine guns mostly utilized add-on suppressors and simpler construction. In budget terms, the carbine represented a high-cost resource. Some committees recommended standardizing on suppressed submachine guns only, and others argued for maintaining a limited pool of carbines. They valued the exceptionally low sound pressure levels documented. Ultimately, a compromise preserved small-scale production without expansion. Design papers list several alternative calibers considered but rejected. Intermediate rifle cartridges required elaborate subsonic load development programs. Smaller pistol calibers produced reduced terminal effect on the targets. The chosen .45 solution remained the most balanced compromise. Mechanical safety devices remained conservative and familiar. The standard Lee-Enfield safety lever was retained. Its location allowed habitual manipulation by trained users. No additional selector levers were introduced into the design. Trigger mechanisms underwent minor refinement during conversion work. Pull weights were kept within infantry rifle specifications. No attempt was made to create match-grade triggers. Simplicity and reliability were prioritized over subtle feel improvements. Documentation also outlines recommended transport and packing methods. Weapons traveled in padded crates with suppressors supported mid-length. This avoided bending moments on the threaded receiver interface. Transit blocks secured the bolt assemblies separately during shipment. Long-term storage procedures included periodic inspection cycles. Preservative oils were applied to both internal and external surfaces. Ventilation ports were sealed with removable plugs to exclude debris. Labels indicated any carbine temporarily removed from operational readiness status. Training material for armourers detailed fault diagnosis and remedies. Common issues included misfeeds from worn pistol magazines. Feed lip deformation and weakened springs were recurring problems. Replacement parts were stocked specifically to address these failures. Another recorded fault involved baffle strikes from misaligned apertures. These were rare but classified as serious incidents. When detected, the suppressor assembly was withdrawn from service immediately. Inspection attempted to determine if manufacturing error or damage existed. Range practices incorporated realistic use scenarios for operators. They were instructed to fire, then hold the bolt. Observation periods followed, monitoring sound propagation and enemy reaction. This reinforced the tactical importance of manual cycling control. Field stripping stripped only conventional components, not the suppressor core, bolts, trigger guard, and stock could be removed normally. The suppressor, however, remained as a monolithic component group. Separate tools and fixtures were kept at centralized workshops only. Technical notes mention modest point-of-impact shift as suppressors fouled. Armourers re-zeroed weapons after major cleaning interventions. Shooter training emphasized verification of 0 before deployment periods. This cautious approach minimized surprises under operational conditions. In procurement correspondence, cost per unit is repeatedly highlighted. The carbine cost far more than a standard rifle. It also exceeded the cost of most submachine guns. Budget managers therefore treated it as a specialist asset. Nevertheless, evaluation committees emphasized its unique performance envelope. At short ranges, few alternatives matched its acoustic discretion. But where single sentries or dogs needed neutralizing, it excelled. In those specific niches, it justified its development expenditures. Post-war, small numbers remained in inventory and storage. Some saw continued limited use in later conflicts. Their presence in armories required updated maintenance and parts plans. By then, however, newer suppressed systems were emerging gradually. Modern reproductions replicate external appearance and broad operating principles. Some use different barrel lengths and updated materials for convenience. They target collectors and demonstration shooters rather than operational users. Even so, core concepts mirror the original engineering solutions. From an engineering perspective, the design illustrates extreme integration. Suppressor, barrel, and action were treated as a unified system. Acoustic performance depended on every dimension and tolerance working together. Compromises in one area demanded compensation in another aspect. The project also demonstrates typical British wartime pragmatism. Existing rifle actions, barrels, and magazines were reused extensively. New components were minimized to conserve machining capacity. Most complexity resided in suppressor manufacturing and precise fitting. Throughout its service life, the carbine remained numerically insignificant. Yet, technical reports show disproportionate attention paid to it. Its measured sound levels influenced later suppressed weapon development. Lessons regarding integral designs informed subsequent prototypes and experiments. Today, surviving carbines appear in museums and controlled collections. They are examined for mechanical detail rather than operational romance. Wear patterns on the baffles show how gas actually travelled. Stock repairs reveal stresses from field carriage and storage. The weapon's story is therefore primarily an engineering record. It chronicles a constrained attempt to solve a defined problem. That problem was sentry removal with minimal detectable disturbance. The solution was a hybrid rifle that sounded like almost nothing.